M3A Navy nuclear power plant, McMurdo Station, Antarctica, supplies up to 1,800 kilowatts of electricity, plus auxiliary steam for snow melting, plant heating, and steam for the water distillation plant. Its normal complement is 25 officers and men. All personnel or visitors entering the plant are required to wear film badges or dosimeters. These monitor any exposure to the radioactivity resulting from nuclear fission. Dosimeters are zeroed through the use of a charger at the beginning of each watch. A console in the plant control room is a central control point from which all operations are monitored and controlled. The operating watch consists of a watch supervisor, a control room operator, on the floor an equipment operator, and a health physicist. These are housed in the secondary buildings, separated for personnel safety reasons from the primary building, which houses the nuclear reactor and related systems. An emergency power diesel unit supplies electricity for plant instruments and equipment during reactor shutdown for normal maintenance at 2,500 operating hours or for other unscheduled maintenance. Uninterrupted power for nuclear instrumentation and other vital process instruments is supplied by the vital AC-DC system. It consists of a battery bank, motor alternator, inverter-diverter, and control devices. Here, the operator adjusts the system voltage. The operator checks the water level in the condensate storage tank. This is replenished by water from the snow melter. The snow melting system, here being checked for temperature and steam supply, provides water for plant makeup and for domestic use of the plant. It has a storage capacity of 3,150 gallons, a portion of which is routed to the steam generator blowdown cooler and other coolers at the secondary sample cabinet. Water from the snow melter is stored in the potable water tank. By lining up valves in this area, the operator prepares to transfer water from the potable water tank through the secondary demineralizer to the condensate storage tank. Appropriate valves at the secondary demineralizer must also be lined up to direct the flow of water to the condensate storage tank. The evaporator feed pump is turned on from the console. During the normal 8-hour startup time, beginning with all primary plant systems normal and ready for operation, 3 checklists are followed. Here, with all electrical breakers properly lined up, the operator racks in the tie line breaker in the 4160-volt switchgear. This breaker is interchangeable with those used in the turbine generator and the station service transformer. An operational check of the air compressors that supply pressure to pneumatically operated valves and controllers. Pressure is maintained above 100 psig. The nuclear instrumentation panel, located at the console in the plant control room, powered by the vital AC-DC electrical system. This is one of the areas checked during the pre-start procedure. The control room operator follows the console pre-startup checklist to ensure the proper operation of all controls and the status of all plant systems. His checklist, like the others, must be approved by the watch supervisor. There, with the primary system solid and free of air, He energizes pressurizer heaters to establish pressure in the system. The vent and drain valves provide a means to vent the pressurizer to the expansion tank in order to relieve pressure in the system. Starting the primary coolant pump and opening the high-pressure demineralizer isolation valve. This puts the purification system in service. During chemical addition, with the demineralizer isolation valve closed to keep chemicals out of the demineralizer, the operator lines up suction to the chemical addition tank. He adds hydrazine before reactor startup to scavenge oxygen from the system. System temperature of less than 190 degrees is maintained by the decay heat pump. A pump control switch located at the console puts the coolant charging pump in operation. Nitrogen pressure in the expansion tank is maintained between 5 and 15 psig. Regulator is located at the HTA package. Before control rods are withdrawn, the watch supervisor makes sure that all requirements and testing are completed and alerts all personnel. When normal pressurizer level is established, rods are withdrawn to bring the reactor critical. Final position must closely approximate the pre-start estimated critical position. If criticality is attained within limits, proceed with rod latch verification. During heat-up, the temperature increase must not exceed 100 degrees per hour. Pressurizer loop temperatures are held within 111 degrees and 255 degrees. The equipment operator readies the condensate system for operation, following the steps in the operating manual. Here he checks the condensate pump valve for proper lineup. He checks the valve from the hot well vent line to the turbine exhaust line for proper position. Another valve lineup. The hot well high-level controller, and the low-level controller. During operation, the predetermined level will be maintained by controllers at the console, functioning in the automatic setting. Here, the console operator makes sure the control system is operational, while the equipment operator monitors the system check. Next, the equipment operator makes sure the condensate line to the deaerator is properly lined up, and simultaneously checks the operation of the controller. This completes the major steps in lining up the condensate system. Lining up the feed water system begins with opening the suction valve to the feed water pump from the deaerator tank. Next, the operator will open the minimum flow line returning to the deaerator tank. Check the valve on the anti-flash line to the feed water pump suction, and check the discharge valve from the pump. Feed water from the feed water heater passes through the flow controller located in the HTA package and goes directly to the steam generator. Here, the operator opens the feed water flow controller isolation valve, lining up valves to the feed water heater. This heater takes steam from the first stage of the turbine to preheat the feed water before it enters the steam generator. At the console, the operator turns on the turbine auxiliary oil pump. Oil must be pumped for 2 hours prior to rolling the turbine to raise the temperature and to process it through the lube oil conditioner shown here. The equipment operator checks water level, pressure, and flow through the conditioner. With steam now available from the steam generator, the secondary plant auxiliary steam boiler can be shut down. During reactor shutdown, this auxiliary boiler supplies the building heating system and plant auxiliary components. Steam requirements will now be transferred to the auxiliary steam system supplied by the steam generator. Now the operator lines up valves to route condensate from various plant components to the deaerator tank. He checks the HTA trap station valves, lining them up to return condensate to the deaerator tank. The same lineup applies to the steam trap at the low point of the superheater steam line. The operator, in preparation for warming the main steam line, lines up all drain valves located throughout the steam system. He closes the steam supply valve to the gland seal pressure reducer. Lining up turbine drain valves, open slightly to drain condensate during warm-up, then close. Now he cracks open slightly the valve on the drain line from the trip and throttle valve, and the valve on the main steam line. Both valves drain to the flash tank. After warm-up, both will be closed. The turbine drain tank system, including pump breakers, are lined up to receive and transfer the condensate from the turbine to the hot well. Now the main steam line will be warmed up using the main steam stop bypass valve. The equipment operator lines up the auxiliary steam line from the pressure regulator to the primary building and closes the valve from the auxiliary boiler. He adjusts the auxiliary steam pressure regulator slowly, increasing the pressure to 110 pounds. The plant auxiliary system is now in operation, using steam from the primary plant steam generator. With steam pressure equalized across the main steam stop valve, the valve is opened remotely. Line up the aerator pressure controller and line up steam trap. The console operator will establish the aerator pressure by operating the aerator pressure controller remotely. Open the deaerator vent to discharge non-condensable gases to the atmosphere. Now the deaerator pressure controller may be switched to automatic. The steam generator level is maintained by starting the feed water pump from the console. Now the console operator fills the steam generator by manually controlling the feedwater flow controller slowly. With primary system up to pressure and temperature, the equipment operator goes to the condenser deck. He ensures proper lineup of power to the condenser freeze protection system. Roll-up doors on the condenser building may now be opened to provide an adequate supply of air. In preparation for an operational check of condenser controls located at the plant console, the equipment operator establishes communications with the control room operator. The control room operator checks with the equipment operator to ensure that the condenser air discharge valves are operational and checks the operation of the condenser main bank louvers. Next, an operational check of the air cooler section louvers. These operational checks are monitored by the equipment operator. Returning to the secondary building, the operator proceeds to open the isolation valve at the desuperheater steam flow controller. The system is now ready for the establishment of vacuum in the condensers. Selecting either of the two air ejectors, the operator opens the valve to discharge overboard. Opening the valve on the auxiliary steam supply to feed steam to the first stage of the air ejector. Opening another steam line valve to place the air ejector second stage in service. Now the operator opens the valve from the air offtake line header to the desired condenser and allows the ejector to evacuate the offtake line. He opens valves to the condenser, opens the turbine exhaust steam inlet valve to evacuate air from the system, and opens the condensate return valve to the hot well. With vacuum established in the turbine exhaust system, the equipment operator notifies the control room that he's ready to roll the turbine by opening the turbine throttle valve. Before admitting steam to the turbine, the throttle must be fully closed and the overspeed trip reset. Next, the operator opens the throttle slowly until the rotor is turning. Next, he closes the throttle valve. He adjusts the gland seal steam pressure and puts the gland seal ejector in operation. Immediately, the control room operator establishes de-superheater steam flow to the condenser. He places the condenser fans in operation to maintain the vacuum. He increases the steam flow and places the second condenser in operation. When the turbine has been rolled and the speed reduced to about 300 RPM, a listening check to detect any rubs, vibration, or other unusual noises. Here, the operator is valving the air ejector to discharge from overboard to the air ejector after condenser. He adjusts the steam flow to the gland seal air ejector. When the turbine speed is up to the lower governor stop and all turbine drain valves are closed, the control room operator prepares to transfer the electrical load to the turbine generator. He raises turbine RPM to synchronous speed. And matches the turbine generator voltage with that of the emergency diesel. He achieves synchronization by closing the turbine generator breaker and immediately assumes the load. With this done, the electrical load is transferred to the turbine generator and the diesel unit is shut down. Here, the equipment operator places the feed water heater in service by opening the valve from the turbine's first stage extraction system. At about 20,000 pounds of feed water flow, the console operator puts the controller in the automatic mode. He puts the feed water flow controller in manual balance and the steam generator level controller in manual. He adjusts the manual control of the steam generator level controller until the feed water flow controller deviation meter reads 0. Then switches the feed water flow controller to automatic. He places the steam generator level controller in manual balance. When the deviation meter reads 0, he switches to automatic. During the day-by-day, watch-by-watch operation of the PM3A nuclear power plant, there are many steps of routine maintenance. An equipment operator checks the temperature and rate of steam generator blowdown. Daily, process control personnel will analyze water samples. These samples, taken from feedwater, condensate, blowdown, and makeup systems, are checked for chemical purity and radioactivity. Here, the secondary water treatment system is being placed in operation. Sulfite and phosphate mixed with condensate are added to the feedwater at the HTA package. At the console, the coolant charging pump suction solenoid valve may be switched to condensate if within limits. The next scene shows some of the plant parameters during normal operation. During his watch, each equipment operator records hourly readings of plant indicator gauges. A maintenance check of the turbine lube oil filter. This is done during each watch. Checking the air ejector non-condensable gas discharge flow rate. This is done frequently to detect any air in leakage to the exhaust system. Another routine check, using the console temperature scan system to detect any abnormal operating conditions. A recorder continually monitors the primary building for any increase in airborne activity. Although it has built-in alarm systems, it is continually monitored by the equipment operator. When either of the holdup tanks is filled, the operator transfers the water to the radioactive waste disposal system for processing. Water taken from the radioactive waste disposal system evaporator overhead is sampled for radioactivity analysis. If radioactivity and chemical purity are within acceptable limits, the water may be reused by transferring to the condensate storage tank or directly to the shield water system. Unsuitable water, if within limits for discharge to the environment, may be discharged overboard. If not within limits, it must be reprocessed before discharge. When the plant water supply, held in the condensate storage tank, needs replenishment, the secondary evaporator is put into operation. The system is checked for proper valve lineup. The evaporator feed pump is turned on. This takes water from the potable water tank and the snow melter. Turn on auxiliary steam. And vent the overhead to the atmosphere. Establish blowdown on the evaporator. Check the water for conductivity and chemistry. Finally, if water is within limits, valve the overhead to the turbine exhaust system. A routine duty for the control room operator, taking hourly readings of console indicators and area radiation monitors. This operator has just left the primary building. After removing protective clothing, he stops at the hand and foot counter to check for spreadable contamination. Health physics personnel continually monitor the plant for radioactivity. This man is seen using a portable radiation monitor. After each 2,500 hours of operation, the plant is shut down for testing. When shutting down for this, or for any other maintenance, inform the base electric shop so they can start base diesel generators and assume the base load. Reduce the plant load. Start the plant emergency diesel and assume the plant load. Then rapidly secure condenser fans, close the superheater steam flow controller, close main steam stop, trip turbine throttle, open generator and exciter breaker, close condenser loopers. Manually maintain level in the HTA package and the level in the steam generator. To shut down the reactor with rod selector switch in the all position and speed selector in slow, operate rod motion control switch to the in position. Adjust individual rods to maintain rod position within 1/2 inch of each other. Should a low pressure annunciator alarm be received, place the low pressure scram bypass switch in bypass to continue with an orderly shutdown. Continue inserting rods until the position indicators are at 2 1/2 inches. Press the scram button. Now place the primary coolant pump bypass switch in the bypass position to reset scram. Turn on the primary coolant pump and return the bypass switch to normal. The rate for reducing primary loop temperature must not exceed 100 degrees per hour. This film report has shown some of the procedures for starting, operating, and shutting down the PM-3A Navy nuclear power plant. For complete and detailed instructions, refer to volumes 1 and 2 of the operating manual.